Today on How It's Made. Car tires. Silk. Art conservation. And scuba tanks. Historically, wheels were made of metal or wood. With the invention of air-filled car tires in the early part of the 20th century, the ride was revolutionized. The inflated rubber tires could better absorb the bumps on the road, and the addition of tread gave the invention serious traction. Car tires have come a long way in the last century. The modern summer tire is made of 10 to 15 different components, which include natural and synthetic rubber, chemical additives, and carbon black, a pigment. Giant blenders mix these ingredients under heat and tremendous pressure. There are various formulations for different parts of the tire. In each case, the result is gummy rubber dough, which machinery then rolls into sheets to await further kneading and processing. Polyester fabric unrolls into a machine called a calender. The calender is equipped with rollers that apply warm rubber to both sides of the fabric. This produces a rubberized fabric that will be used to reinforce the tire. This fabric ply is needed because rubber alone isn't sturdy enough to make a tire. Numerous cotton cords now spin off bobbins simultaneously. Machinery pulls them onto the warm rubberized fabric. They land on a bit of an angle and adhere. This cording creates channels that provide pathways for venting air during the actual tire building. Making rubber for tread requires 3 different rubber formulations. Extruders shape the 3 streams of rubber, and then they enter a die that forms them into one. Many paint rollers apply different colored stripes. It's a coating system for identification of the ingredients during processing. To avoid tension, the system creates slack in the feed. A blade slices the tread rubber to length. Next, many steel cables uncoil at once to make the bead, the part of the tire that gives it the strength it needs to stay on the wheel rim. Machinery arranges the cables in the desired configuration and encases them in rubber. More equipment rolls the bead material into hoops, sized to fit the wheel rim. They're now ready to build the tire. Using a special rotating drum, a worker arranges the 2 bead hoops on it. Next up is an airtight piece of rubber that will act as an inner tube, followed by the corded ply. Inflated bladders roll the rubber around the bead on both sides and then retract. A server applies sidewalls to the beads. Little rollers fold the sidewalls over the beads. This completes the inner part or skeleton of the tire. They assemble the outer layer separately, beginning with strips of rubber embedded with steel cord. The system wraps this rubber around a second tire building drum. Next up are narrow strips of rubber ply. The computerized system winds them with just the right amount of tension for a graduated effect. They're now ready for the last layer, the tread rubber. Machinery applies it to the ply. It's time for the 2 tire fabrications to become one. A transfer ring collects the assembly and transfers it to the inner part. Compressed air inflates the tire to shape it, and all the sticky layers adhere together. The machine rolls the edge of the tread rubber over the sidewalls. They now have what's known in the industry as a green tire, an uncured tire without tread pattern. Next, it's into a mold to bake and shape the tire. The 2 parts of the mold come together like a waffle iron. Inside, hot steamy bladders expand to shape the tire and transfer the tread pattern to it. This specific tread pattern is designed for summer tires. This cutout of a car tire demonstrates how all the layers have been fused together. The time in the hot pressurized mold has caused the rubber to vulcanize, a chemical reaction that transforms it from a weak and sticky substance to one that's strong and elastic. A worker trims excess rubber. After final inspections confirm the tire shape is uniform and geometrically correct, the tire is ready for shipment. It's time for the rubber to hit the road. Silk fabric originated in China at least 5,000 years ago and became a coveted luxury. Silk thread is produced by silkworms when they make their cocoons. Sericulture, or commercially breeding silkworms for silk production, is practiced in several Asian countries. From home goods to accessories and clothing, there are few textiles as elegant and luxurious or as prized throughout the ages as silk. It's hard to believe this beautiful fabric comes from worms. The female silkworm lays up to 400 eggs in one shot, then promptly dies. Each egg, about 2 weeks later, hatches into a larva. The larva feeds on fresh mulberry leaves continuously, increasing its body weight 10,000-fold and growing to a length of about 3 inches. Then, as it enters the pupa phase of its life cycle, it excretes liquid raw silk from salivary glands in its mouth. When that liquid silk contacts with the air, it hardens into a single thread. Pupating larva winds that thread around itself into a thick, cozy cocoon. Normally, the pupa inside becomes a moth, and the cocoon breaks as it emerges. However, this severs the continuous silk thread. So to keep the thread intact, they boiled the cocoon for about 3 minutes to kill the pupa inside before it transforms into a moth. Boiling the cocoons also makes the wound thread easier to unravel by melting away most of the sericin, the gelatinous protein that binds it. To harvest the silk, they take threads from 30 to 50 cocoons at a time. They feed them all together through a hole in the bamboo stick onto a hand-operated reel. Then, slowly and carefully, they turn the reel, unraveling the cocoons. As the thread passes together through the stick, the remaining sericin glues them together, forming a single thicker thread. The silk threads coming together are so fine, only about 1/100th of a millimeter in diameter, that it takes 2,000 to 3,000 cocoons to produce a pound of silk thread. Unraveling cocoons is a time-consuming process because a single thread can be as long as 9 professional soccer fields. To make this feather-like silk thread easier to handle, they weigh it down with sand before rolling it into a bundle. Next, they wash away the sand and remaining sericin, then bleach the thread so it will uniformly absorb this synthetic dye. It's critical to monitor the ratio of dye to hot water, as well as water temperature and soaking time, as all these factors combined affect the quality of the color. After rinsing away the excess dye with lukewarm water, they hang the thread to dry. They mount the bundles of dry dyed silk thread on a big machine, which transfers them to smaller rollers. Those rollers then go on an automated machine, which transfers the thread to small bobbins. To craft silk fabric, weavers will pass bobbins of thread horizontally between vertical threads on a traditional hand-operated loom. Another machine, meanwhile, winds thread around spools. A worker then installs a set number of spool threads on a mechanism, which aligns them vertically on the loom, parallel to each other. Fabric that's about 3 feet wide typically requires 4,000 vertical threads. By stepping on the loom's foot pedal, The weaver repeatedly raises every second vertical thread, and with a tug of a cord, passes a shuttle containing a bobbin of thread horizontally in between. This intertwining of horizontal and vertical threads weaves the silk fabric. To create a pattern, the weaver uses multiple shuttles containing threads of different colors, thicknesses, and textures. Some patterns, such as an intricate weave called brocade, are so intricate that even the most experienced weavers produce just 2 to 6 inches of fabric per day. Now that's wearable art. A centuries-old painting is actually easier to restore than a decades-old painting. For hundreds of years, artists used pure oil paints, but by the 20th century, artists began using different types of paint, making restoration more challenging. A traditional painting is typically oil on canvas, protected with a layer of natural resin varnish. Over time, a linen canvas can become brittle, distort, and sometimes tear. Varnish yellows, and dirt and dust accumulate, rendering the once vibrant painting dark and dull, and in dire need of professional conservation. The conservation process is multifaceted. They have to strip away any previous restoration, then perform a new restoration, yet make it entirely reversible to allow for future restoration. The conservators begin with spot tests to observe how different colors in the painting react to cleaning. They dip a cotton swab in mild detergent and rub gently, testing for discolored varnish and any previous restoration. When all that's done, they swab on some solvent to neutralize the detergent residue. Next, they spray the back of the canvas with water and lie the painting on a vacuum hot table. The heat turns the moisture to steam, which relaxes the paint and linen, as the vacuum pulls the bumps and puckers flat. If the canvas isn't structurally sound, they apply adhesive, a synthetic backing, then a new linen canvas. With thermometers monitoring the temperature, the heat activates the adhesive, and the vacuum draws everything taut against the hot table, bonding old linen to new. And the conservators can turn their attention to the artwork. They begin by mixing a cleaning solution, 1% chemical-grade ammonia, 20% strong detergent, and 79% water. They dip a swab in the cleaning solution and another in the solvent. Working a small area at a time, they gently glide the cleaning solution swab over the surface. It's critical not to rub, as any abrasion could harm the painting. Next, they gently roll the solvent swab over the same area to neutralize the cleaning solution residue. They repeat this solution solvent procedure area by area until they've removed surface dirt from the entire painting. Then they start all over again, this time removing old yellowed varnish, embedded dirt, and previous restoration. The cleaning completed, they can now address the tears and damages. Using a small palette knife, they fill the cavities of the tear with gesso, a material that's used as a background for paintings. This gesso is reversible, meaning it can easily be removed if required during a future restoration. Once the gesso dries, they wipe away the excess with a damp cloth, leaving a repair that's flush with the surrounding surface. Then they seal the gesso with varnish. This creates a barrier between the existing paint layer and the one they're about to add, making it removable for future restoration. They retouch the repaired area, expertly matching colors to the original and blending them seamlessly with the surrounding area. This process, called in-painting, is where the conservator's fine art training is put to the test. Rather than use oil paints, they mix pigments with acrylic resin. This produces paint that looks just like oils, but is removable with mild solvents in the event of a future restoration. They brush varnish over the in-painting so that the sheen matches that of the surrounding area. And now, the final step. They spray the entire painting with a light coat of removable synthetic varnish that doesn't yellow over time. This evens out and protects the surface. Once the varnish cures, the painting goes back into its frame, just the way the artist intended. Underwater exploration was a shallow experience until scuba tanks were developed in the middle of the 20th century. Filled with compressed air and attached to a breathing regulator, scuba tanks enabled divers to stay underwater longer. This invention took diving to a whole new level. Scuba tanks are a way to bottle the air we breathe and take it with us underwater. To make aluminum scuba tanks, they start with solid cylindrical chunks called slugs. The aluminum alloy slugs tumble around in a perforated rotating drum, which takes them through a series of chemical baths. The baths clean and treat the surface of the aluminum to prepare the slugs for forming. The operator loads the slugs into a feeder system that serves them up, one at a time, to a hydraulic extrusion press. An extrusion piston forces the slug into a die inside the press. It hollows and stretches the slug into the shape of a scuba tank. It takes about 1,300 tons of force to transform a solid short chunk of aluminum into a longer hollow cylinder. The shaping process itself generates heat, making the aluminum softer and more malleable. The press establishes the outer diameter of the tank, the inner one, and the base. The process takes just 20 seconds. The freshly formed cylinder now spins as a roller applies a lubricant to the open end. The machine ejects the cylinder. Then it's over to the hydraulic neck press. This press forces the opening of the tank into a die to narrow it substantially. This establishes the basic shape of the scuba tank neck. It still needs more work, but first, the tank shape must be firmed up. They heat treat and then quench the scuba tanks in cool water. The shock of the rapid cooling hardens the aluminum. Back to the neck now. A spinning computerized cutter shortens it. Then another cutter moves in. Filings fly as it carves excess metal from the outside of the scuba tank neck. A computerized drill widens the neck hole and cuts a pocket for an O-ring seal. The next tool carves a thread into the inside wall of the neck. The threaded profile will allow for connections to an air fill-up valve and to a breathing regulator. Every scuba tank undergoes a test to measure tank expansion under pressure. They fill each scuba tank with water and place it in a test jacket that's also filled with water. Testing equipment increases the pressure in the scuba tank, and the tank expands, placing water from the test jacket. By measuring the displaced water, they determine the rate of tank expansion, and if it's acceptable, the tank moves on. A scuba tank now spins against a sanding belt. This sanding gives the exterior a brushed finish, which some divers prefer. etch the serial number and other information onto the upper part of the tank. For a more colorful look, the factory applies a vibrant translucent powder coat to the brushed finish. The finish is purely aesthetic. Aluminum doesn't rust, so a natural finish would weather underwater conditions as well as the powder coat. They bake on the powder coat, giving the tanks a glossy look. These aluminum scuba tanks are now ready to take the pressure. Life is sure to be one underwater adventure after another. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.